Go.
So we were asked to solve this equation for x. Because the expression is set equal to 0, that tells me that we're looking for specific values of x. So to solve the problem, we will factor the expression, set each factor equal to 0, and solve for x.
Alright, so first step, we take all possible factors of the last term, which is plus 2, because the possible factors of those can become possible factors of the entire expression. So we bring our movie over here, and those factors are called the p-values. So those values are plus or minus 1 and plus or minus 2, because both of those numbers could be multiplied to get 2. So using factor theorem, which is when p at k equals 0, x minus k is a factor, we take any of those values and sub into the original expression. So we started out with 1, so p at 1, and we sub that in to the original equation, which turned out into that. We simplified further, which became that, which ended up to equal 0. So that means that x minus 1 is a factor. We got that the first go, so that was really helpful. So now we divide x minus 1 out of the original equation to get what is left, which will determine what our next line in solving is. So using synthetic division, we take the coefficients of the terms of the original equation, which are 1, 1, negative 3, negative 1, and 2, which is because 1 there, negative 3 there, negative 1 there, and 2 there. And we have the term of the factor right there, and this is how synthetic division works. We subtract going down from here, so that's 0, so we can just bring that right down. We multiply that, the term from the factor, to that term, bring it up there because that times that equals negative 1. We subtract going down, so 1 minus negative 1 equals 2, and we continue that process right into the end, and we find that the remainder, which is the last value, is 0. So that confirms that we were right, that that was a factor. So we take these values and put them as the coefficients of another expression, which is what we have left. Which is x to the 3 plus 2x to the 2 minus x minus 2, and the remainder is 0. So that brings us to our next line in the equation, which is we factored out x minus 1, and therefore x minus 1 times x to the 3 plus 2x squared minus x minus 2 equals 0.
So the next step is to factor this new equation in the same method we did for this equation. So first we have to find the p-values using the last term. Since the last term is negative 2, the p-values are once again plus or minus 1 and plus or minus 2. So we started with 1, and once again the value of p at 1 ended up equaling 0, which tells us that x minus 1 is a factor. So we used synthetic division once again, following the same process from before, and that gave us our new equation of x squared plus 3x plus 2 with a remainder of 0. So that brings us to our next line, where we factored out another x minus 1 and our new equation right here. So now we have to factor this equation, and since it's just a quadratic, we can do so using decomposition. So what we did here is we have to split this term into two values that multiply to 2 and add up to 3. So two values that do that were 1 and 2. So that gave us, with our final equation after we factored by grouping, of x plus 1, x plus 2, which brings us to the factors of our equation, fully factored in factored form.
So because the whole equation equals to 0, that means that each factor could equal to 0 to make the expression true. So that means that x minus 1 equals 0, x minus 1 equals 0, x plus 1 equals 0, and x plus 2 equals 0. So simplifying all those terms, we can find that x equals 1, x equals 1, x equals negative 1, and x equals negative 2. So because these two factors are the same, that means on a graph, the two roots, this would mean that it would be one single root, but it would be a bounce point. And there are the solutions for x.